So let us see on how we can be able to sketch the graphs of the reciprocal functions. Let's say we have the function y is equal to, let's say, 1 over x. So this is a typical reciprocal function you should have to understand. And how do it goes about? And the nature of the reciprocal function graph, let's say in this case, goes like this. Let's say this is the Cartesian plane, and where this is the y-axis and this is the x-axis in that case. And the graph of the reciprocal function, our lines like this. So this is the basic graph of the reciprocal function. You should know. That's how it happens. Where in this case, this is actually a horizontal asymptote, which is given as x-axis, or we call it as y is equal to 0. The horizontal asymptote, it is given as the x-axis. That is the horizontal asymptote, which is the same as calling it as y is equal to 0. That is the horizontal asymptote. And while the vertical asymptote, it is given as this line. And what is that line? It is now the vertical asymptote. We have it as, should be y-axis. So we have it as the y-axis, or we call it as the x is equal to 0. That is the vertical asymptote. Mind you, asymptote, it is the line in which the graph cannot pass through or touches that. So this is the typical graph of the reciprocal function, which happens to be the mother graph. And how about the reflection of the graph goes about? How the reflection of the graph also happens to be about. So now, let's say we have a negative 1 here. If we have negative 1 here, it means the graph will reflect along x-axis. And this is how the graph will look like. So the graph will look like this. Upon reflecting along x-axis, the graph will look like this. Then the graph will be like this. Let me have it proper here. Then the graph will look like this upon reflecting along x-axis. And likewise, even the reflection along actually y-axis. Let's say if we have negative, let's say x here, the graph will also look in the same way. So keep that in mind. So now let's say we have, in this case, let's say we have, so by the way, make sure that before you go for this, you have gone through the techniques in the graph sketching, because those are the ones that we should have to use, or we are using in this lesson. So make sure that you have gone through those techniques. Let's say we have 1 over x, and let's say plus 4. So in this case, this plus 4, it is the translational determinant along actually y. Since it is positive, it will be translated upwards along y-axis. So in this case, since actually this 4 is along here, it means it is the translation determinant along y-axis, which means the graph has to shift upwards along x-axis. So in this case, we'll have the basic graph of the reciprocal, which should be given as this. Of course, this is the basic graph of the reciprocal function. which is given as this. That is the basic graph you should know. Then the graph we are looking for, it is the one that is being shifted 4 steps up. Let's say this is a position 4. Then I will have to draw actually a horizontal line, and it can be the dotted line passing through the point. So in that case, what it means is that the graphs has been shifted 4 steps up along x-axis. It means this graph will now be like this. So which means the graph will be drawn like this. And also this graph has been shifted 4 steps up. It means we'll have them this way. So that's how the graph will be actually drawn. So for this case, we have the actually horizontal asymptote, which happens to be actually y is equal to 4. And the horizontal asymptote is given as y is equal to 4, which is this line. In the vertical asymptote, it is given as the vertical asymptote should be the vertical asymptote. No, should be the vertical asymptote. It is given as the y-axis, which is this line. So now you can see that the graph is having the actually x-intercept here. So what is the value of that particular x-intercept? Then we'll be required to solve for the x-intercept, and for this case, where on the x-intercept y is given as 0, then we'll be required to solve for x in that way. So on that case, we'll have it as 0 is equal to, now have 1 over x and plus 4. Then we multiply everything by actually x, that will be given as 0 is equal to 1 plus 4x. So now which means we have x being given as negative 1 over 4. So which means the x-intercept here, it is given as, this is the point where it corresponds to actually x negative 1 over 4. That is how you just have to understand that and up to. So as you can see, the graph has no y-intercept. The graph has no y-intercept because even the equation itself, as it suggests, we know that the y-intercept is obtained upon having x as r. So in this case, it is impossible to have x as r there. So the graph has no actually y-intercept. So keep that in mind. Now how about if we have this nature of the function? Let's say this is the case. Let's say we have a function given as y is equal to, let's say is given as negative 5 over, let's say 2x, and minus 4 plus, let's say, a 2. So now this is also the typical reciprocal function you should have to understand. And in that case, we'll come up with a Cartesian plane where the sketching will be done. So everything should be scribbled using the pencil. So this is the y-axis, and this is the x-axis. So what is happening is that the graph, we are having the translational determinants along x as well as the y. So in this case, the graph is shifting about 2 steps up, so which means let's say this is where the 2 is. Of course, you'll be supposed to come up with actually a scale, the convenience with respect to the values that you're having. But let's say this point is given as a point 2. Let's say that is the 2 of our interest. Let's say this is the 2. What's going on here? Let's say this is 2. Like that. Then the graph has to shift about 4 steps to the right. So let's say this is a position 4. Then we are going to have the dotted lines. We'll have the horizontal line going over like that, and also have the vertical line going over like that, in that way. And on the same case, we have the reflectional determinant along x-axis. So which means instead of having this kind of the graph, then the graph is going to reflect along x-axis, and that will be given as this. So this is the graph we are looking for in that case. So now, since the graphs can be basically be drawn in this way, and can be also being given in this way, then the graph will have both x-intercepts as well as the y-intercepts. But let's first of all have to highlight what is the horizontal asymptote. So now the horizontal asymptote, it is given as x is equal to, which is this line, should be y is equal to, rather, should be y is equal to, should be y is equal to. That is the value of the horizontal asymptote. Then how about the vertical asymptote? The vertical asymptote, it is given as the x being given as 4, which is this line. So keep that in mind about the asymptotes, how we'll be able to have them in that way. Now, how about the x-intercept, which is this point? So the x-intercept will be obtained upon having y is equal to 0. Hence we'll have 0 is equal to, let's say, negative 5 over 2x, and minus 4, and plus 2. So can you deduce what is the value here on the actual x-intercept? On the same case, the y-intercept here will be deduced upon having x is equal to 0. So which means if you substitute the x being given as 0, then you'll be able to have, let's say this is the 0. It means we'll have now 5 over 2, and should be 5 over 4. We'll have it as 5 over 4, and plus 2, which is about 2 point something, in which is really in line with where the graph will cut across the x-axis, actually y-axis. It should be will cut across the y-intercept. So this is the y, where the y-intercept will be obtained in that case. So keep that in mind. And let's say this is the actually function where we have y is equal to, let's say, negative, let's say 2 divided by, let's say, x, and that should be plus, let's say, 4, and let's say minus 2. So what will be the graph of this function, and you specify the intercepts where necessary, and also the asymptotes where necessary as well. In our principle remains the same. This is the y-axis, and this is the x-axis. And we have the translational determinants along x as well as the y. So along y we have 2 steps down. So which means, let's say this is where 2 is. Now have this one as negative 2. And the graph is translated along y-axis, that is x-axis, 4 steps to the left. Let's say this is 4. So have negative 4 here. Then now we'll have to come up with the vertical line and also the horizontal line going over like this. So in this case, we also have the translation reflection determinant, in which the graph is reflecting along, and that should be along x-axis. In that case, the graph will be this. So this is the graph of our interest according to the way the function is. So the graph will be drawn in this way. So as you can see, we are having the actually x-intercept, and we are also having the y-intercept. It's possible as well in which the graph will cut across the y-axis at this point. So you can be able to have the x-axis should be x-intercept and also the y-intercept in that case. In this case, this is the vertical asymptote, this is the horizontal asymptote. So keep that in mind. And also try to have this at your own time, and appreciate how you can be able to have that out. Let's say we have y is equal to, let's say 2 over x minus 5 plus 4. Let's say we have y is equal to negative 3 over, let's say, negative 5x, let's say, plus 2. So try to have the graphs of those functions. Let's say have y is equal to negative, let's say, half, and divide by, let's say, 4, and plus x. What will be the graph of this function? So try to have the solution of that and how the graph is going to look like. So now sometimes we can also have this kind of cases. And let's say we have the function y is equal to, let's say, 2x and plus 1 divided by, let's say, we have 4x. Let's say, we just have it this way. Let's say this one should be given as 4x. Let me just have to give it as, let's say, I should have it as 2 here, and plus, let's say, 10 in this case. So now, how should we be able to come up with the graph of this function? It's true more, this is the reciprocal function, and which corresponds to the rational function. Now, in order to have to come up with the graph of this function, we should have to make sure that the graph, the function, it is in the actually a nature where we have a plus, let's say, should be b over c. In other words, it should be part of a typical reciprocal function in that case. So since both the numerator as well as the denominator, we have the highest degree power given as 1, then this is how it has to be. But before we go for this one, I would like you to understand about this thing. Let's say we have 10 divided by, let's say, 3. So now having this case, it is the same as having it as this. No, this is 10 and this is 3. And in this case, we call this one as a divider. And this is said to be a dividend. So in this case, we'll have 3 into 10, we'll have it as 3. And the 3 times 3, we have it as 9. Minus, we have it as a 1. So now, this is now a remainder, this is a divider, and we call this one as a quotient. Let's say this is the case. Let me call this one as A. Let's say this is B, and let's say this is given as C. So now at the end of the day, having 10 divided by 3, you see that, now let me have it this way. Having 10 divided by 3, you should have to understand that should be divided by 3. It is the same as having it as a quotient, which is A, plus the remainder, which is C, divided by the actually a divider, which is given as a B. That is the same as that, even if you can also be able to prove. For instance, we have actually a quotient which is given as 3, and the plus, let's say, remainder 1 over 3. Let's see what will happen. So have this one as 3, so which means we have 3 into 3, 1, and 1 times 1 is given as 1. The plus, this is a 9, so which means it is the same as 9 plus 1, which is given as 10 over 3. So that is the same as that. Now you see that it is the same. So that's the principle we should have to use in order to have the graph of this function. And also recall about the wrong division method of the actually. You should also recall about the wrong division method on how we divide the polynomials. That is how to find the remainder using the wrong division method. So let's use the same principle here. In this case, we'll have it as this. This is 2x. Now in this case, we have it as this. We have 2x we have 2x plus 10, and we have divided by 4x and plus 1. That's what is happening there. So in this case, we'll have 2x into 4x. That will be given as 2. Now we'll have it as 2. Then 2 times actually 2x, we'll have it as 4x. And then 2 times 10, we'll have it as 20. That is minus. That is a minus. Now 4x minus 4x is given as L. And 1 minus 20, we have it as negative 19. So now, which means having this actual function, it is the same as having it as, now this is the same as having it as 2 minus, that is 19 divided by 2x and plus 10. That now you can be able to come up with a graph of this function, which is the same as the way we discussed about before. Of course, having this case, it is the same as having it as y is equal to negative 19 over 2x plus 10 d plus 2. That is the same as that. Now you can be able to come up with a graph of that function and be able to determine the asymptotes and also the intercepts. Now let's say we have y is equal to, let's say x minus, let's say 5 divided by 4x and plus 2. Now principle remains the same. First, to be able to have the graph of that one, we need to use the long division method in order to have it in a proper form. That will be given as 4x and plus 2 like that, and you have x minus 5 in that way. Now 4x into x, we have it as 1 over 4. That is, then we'll have 1 over 4 times 4x, that will be given as x. And 1 over 4 times 2, that is 1 over 4 times 2, that is the same as, that should be plus 1 over 2. And the minus in that way. The next we'll have negative, actually x minus x, that is given as L. Then we have negative 5 minus half. What would be that? We have it as here 2, that is given as 1, should be negative 10. Here minus, we have it as negative 11 over 2. So it means we have negative 11 over 2, of which it is about negative 5.5. That is the same as that. So which means having this one, it is the same as having it as, now should be about negative 11 over 2, and that divide by 4x, and that plus 2, and that plus 1 over 4. And of which this is the similar to be calling as negative 5.5 over 4x, and that plus 2, and that plus 1 over 4 corresponds to 0 point something. Now you can be able to come out with the graph of that one, and be able to identify what are the asymptotes and also the intercepts as well where necessary. And also check this one out and try to have the solution at your own time. Let's say we have y is equal to, should be 5x minus 1 over, let's say, 3x plus 1. And also try this one. We have it as 4x plus, let's say, 10 over, let's say, x minus 5. So try to have that of the graph of those functions, and I'll also be able to deduce the intercepts as well as the actually asymptotes. So don't forget to subscribe to my YouTube channel, and I saw that such stuffs should keep on being produced and for you to benefit. Thank you.